Okay, welcome to Swift. This is Unit 1, Lesson 2. We're going to go over the entire lesson, which is on constants, variables, and data types. If you took Java or C++ prior to this is going to be a pretty simple lesson. There are a few things that are different. So let's just take a look. It should be a pretty quick lesson. Okay, so constants and variables associate a name with a value, defining a constant or variable. When we define a constant or variable, we're allocating storage for the value in memory, and we're associating the constant name with the assigned value. So think of variables and constants just like in math, where you have variable x, or you have a constant like pi is 3.14. So here's how we define a constant. We're going to use the keyword let. So if that keyword is there, it tells the compiler that name is a constant. And what happens is if we define this as a constant, we cannot change the name ever in the program while it's running. So it protects that constant. So we would say let pi equals 3.14159, or let name equals John. So if we do this, and then later on in the code we say name equals James, then we're going to get an error, and the error is going to say cannot assign to name. It's pretty small. What does that say? It is a let constant. Okay. So those are our constants. Our variables are going to start with the keyword var. So we write var, we write the name of the variable, and we assign it a value. If we do this, then we can, anytime in the program when it's running, we can change the value of age. We can ask the user to input the value, or just somewhere else we can change the value by assigning it any number. So here we have a constant called default score of 100. We have two variables. One is player 1 score, player 2 score. And what we're doing here is we're saying, okay, we're going to start each of our players with a default score of 100. Everybody starts with 100. Then we have two print statements, and it prints the score of player 1, player 2. Again, these are variables. Then we change player 1 scores to 200, and we print it, and this is our output. So this printf prints 100, the next printf prints 100, and the last print, not printf, I'm sorry, the last print prints 200. Printf is for C programming, not Swift. Okay, the next slide. So this is just a little example of this car taking a trip, and so we're asking, is this constant or a variable? So if you look at the starting location of we take our trip, the starting location would, could be a constant, and then destination could be a constant, but then your current location and your distance traveled and your remaining distance would be variables, because it changes as you travel. Okay, so naming our constants, we have some rules that we have to follow, and we also have some conventions. A rule is different than a convention. A convention is what it looks like, and the compiler doesn't care. A rule, we actually have to follow them. So they have to, our constants and variables cannot start with a mathematical symbol like plus, multiplication, division sign, equal sign, those kinds of things. So we can't have any kind of mathematical symbol either at the beginning or in the middle of our or anywhere in our constant or variable, because if we have something like n and then a little asterisk and r, it thinks that we're trying to multiply n times r, so that's why we don't use that. So those are reserved for doing mathematical equations. We can't have spaces in our names, because if we have a space, the compiler thinks that we're starting something new, a new command or a new variable, something new is happening. And we can't begin with a number, because if we start with a number, the compiler thinks we're going to now use that number in a calculation. So in this example, we have n, we have some symbols here. This is not a minus sign. This is another symbol. This is just a word. It's in Spanish, morning in Spanish. And this is just a variable name, constant name. And we've used what we call a camel convention of how we define it, so we can tell that this is a different word from this one. Okay. This is something that you need to know, and the computer will tell you if there's an error. The compiler will tell you if there's an error. So we have best practices or conventions. Best practice is that you use a clear and descriptive variable or constant name. So don't use n, but use the first name. Don't use a, but use age. Things that will make sense. The code needs to be readable. Again, we're going to use the camel case. So if you're starting, you start with lowercase letter, and then the next, if there are two words in your variable name or constant name, start it with a capital letter. This is not required. Your compiler, your code will compile just fine without errors. Again, this is best practices. In a company, you would have, they would tell you exactly how they want you to name variable names, and you would have code reviews. People actually look at your code and review it just like they review, let's say, a book that you write. Okay? All right, comments. Comments start with 2 forward slashes. A comment is not processed by your compiler, so it just skips that line. And you can also add a comment with a / asterisk, asterisk /. This is how comments were done in C programming when C first came out. Remember, Swift has some of the same, it comes from Object-C, so it has some of the same things that C programming had. And then when Java, I think it's Java, maybe C++ came out, we had the 2 forward slashes, so you can use either one. Here we're defining a constant. Okay, this is called a type. It's a structure, and you don't have to know a lot about how to use it right now. You'll learn about it later. But a structure is a data type, and here we're saying that this structure is called person, and within person, we're going to define the first name, last name, and a function. Don't worry too much about this. Here we have another structure. Notice here that we say let first name :string. What we're doing here is we're defining first name as a string variable. We're actually giving it the data type. We'll talk more about this in a minute. Here we're saying that a person equals person. This is the data type person that we defined here. So it's not a string, it's not an integer, it's a person, and it requires 3 things. It requires, not 3 things, 2 things, a first name and a last name. Okay, so our most common data types are integers, doubles. Integers represent numbers like 1, 2, 3, 4, -1. Double represents numbers requiring decimal points, 13.45. Boolean represents true or false, that's it. And strings represents anything at all that you put inside quotes. So any character you put inside quotes is a string. Type safety. So here we say let player name equals Julian. What happens here is that the compiler itself will say, oh, Julian is in quotes, so this is a string, and it defines it as a string for you automatically. And then here we have player scores 1,000. Automatically it knows that this is an integer. What happens here is if you try to assign player name, which is a string, to player score, which is an integer, you're going to get an error. And it says cannot assign a string to an integer. Here you have an integer, and here you have a decimal number. If you try to assign the decimal to the integer, it says it cannot assign the type double to an integer. So it has type safety for you. It gives you an error. This happens in all compilers. Let's see here. And then this here is just talking about how if I just say city name equals San Francisco, automatically the compiler makes city name a string data type, and it makes pi a double data type. But I can also tell it what data type I want it to be. So for example, let's say that I want to let number be a double. And the reason I want it to be a double is because it could be a whole number or it could be a decimal number. So I give it the double data type and then I assign it a 3. That means that when I output the number, it'll be 3.0. But if later on I assign it 3.5, it still works. So here I'm not letting the compiler decide. I am deciding what I want the data type to be. Okay. So this is 3 common cases that we would give it a data type. Number 1, you define this constant first name and you say it's a string. And that's all you do. You don't tell it what the string is. Later on in the program, that's what this ... is. Somewhere down the program, you say first name equals whatever. So this would be one reason why you have to give it the data type, because you're not giving it a value. Another reason you would give it a data type is that maybe you create a constant or a variable that could be inferred as 2 or more different types. For example, the letter J, we're going to say that this is a character, and if I don't make it a character data type, it automatically would assign the string data type because it has the double quotes, the quotes on there. This one, float, is another data type. Float is like the double data type, except is smaller in size. It takes less space in memory. So once again, I'm assigning it a whole number, and what that means is my distance may be 30 miles, my distance may be 30.5 miles. So I can either be for a float or a double, I can either assign it a whole number or I can assign it a decimal number. But with integers, I can only assign it whole numbers. Okay, so this is your struct again, the structure data type. Here I say car has 3 properties: make, model, and year. and they're going to be strings, 2 strings and an integer. I don't give it the values. Maybe later on I ask the user to enter the values and I assign the values to my struct car. Okay, so here if I just type in var x, I'm going to get an error because I didn't say var x equals something. I either have to say equals something or I have to give it the data type. So I can do that, and that's okay. I can't print x because I haven't assigned it any value. So it's going to say variable x is used before being initialized. And actually it doesn't give me an error, it gives me a warning, I believe. So here we have now we define variable x as an integer, we assigned x a 10, we print x and it prints the 10. Sorry, I clicked on that. It prints the output 10. Okay, literal formatting. So this is just saying if you have a really big number and you want to really show easily that this is how big this, where the comma should be, so you can read the number easier, then you can use underscores. You can't use commas, you can only use underscores. Okay, this is the end of Unit 1, Lesson 2. What you're going to do now is you're going to open and complete the exercise in the lab called Constants and Variables.Playground. So remember, you've downloaded the student files. Mine are... So what you can do is you can go back through here. If I went too fast or there's some stuff you didn't understand, you can read. Actually, this is the teacher book. Let me open the student book. Oh, goodness. Okay, let's see here. There we go. I don't use iBooks often, as you can tell. So we're going to go to App Development Swift, and then here's Lesson 1, 2. And it's going to go through all this again that I just went through. You can review it. Take notes. If this is the first time you've seen all this, I would definitely go through and read it and take some notes. Go through and do these 7 review questions to make sure that you understood the lesson, and then complete the lab. So let me get all this out of the way. Here's my student resource folder. I'm going to go to getting started. I'm going to go to constants. So this is Unit 1, and this is Lesson 2, constant data types. I'm going to open the lab, and then I'm going to open it one more time. This is the actual file, the Swift file. Remember, it has a little bird. And are you sure you want to open it? Yes, I want to open it. Okay, so this is my lab. And I'm going to read the instructions and I'm going to follow the instructions. I'm going to do what it says. So first it says, declare a constant called friends to represent the number of friends you have on social media. Give it a value between 50 and 1000. Print out the value by referencing your constant. Okay, so if I'm doing a constant, I have to type in let. I'm going to type, they told me that I had to name it friends, so I'm going to name it friends. I'm going to assign a number. I don't have to give it the data type. So let's say that on social media I have, I don't know, 400 friends. Oops. There we go. And then the next thing that I want to do is I want to print, it says print out the value by referencing your constant. By the way, it said to give it a value between 50 and 1000, so don't go crazy. Okay, so we're going to do that. And I'm going to put friends. And then notice that it says it outputs 400. Now if I put quotes around friends, it's no longer the constant. Now it is, notice that what it outputs is the word friend. So putting quotes around it outputs the actual word. So I don't want to do that. I just want the variable. Okay, notice here on the right that it outputs. If for some reason you don't see that, just click this play button and you should be able to see the output. Now you're going to go through the rest of the lab. Notice that this has 10 pages. This is page 1 of 10. So you want to go through all the pages, and then, so there's page 2, next exercise, all the exercises. And then what you want to turn in is take a screenshot of, you don't have to take a screenshot of every single page, at least just let me see the last few pages. Okay. And then you're going to upload that screenshot of maybe 1 or 2 pages. Just want to see what you've done here on the lab. Okay? Thank you, and please email me again if you have any questions and concerns. I really hope that you take notes as you watch these or as you read the book.